Okay, hi guys, it's Mr. Brown here. We are now going to talk about something called acceleration, and I think most of you have probably heard the word acceleration before, but maybe you're a little unclear about what it means. Acceleration just really means for something to get or start going faster. So you've all experienced it. If you've stopped at a red light and then you start to take off, you're starting from a velocity of 0 meters per second. You're starting off at rest, and you're continually increasing your speed all the way up until maybe the speed limit was 60 kilometers an hour. So acceleration just really is the concept of getting faster and faster and faster over time. The way that that looks as a formula is this first one over here. So, oh, okay. So right here, okay, my pen's working now. This formula right here is showing that acceleration, so we write that as an A. And one little thing that's missing here is this should be an A with an arrow over top of it. And if you remember why we put an arrow over top of things, that means it's a vector. So we do care about the direction that the acceleration is in, so we write a little arrow over top. But anyway, so this formula here is showing that acceleration is equal to, and remember this little triangle here, that means change in velocity. So change in velocity, that just means that we are getting faster and faster. So our change is going to be how much did it change. On the bottom, you're going to also see a change in time. Don't worry about it too much. That triangle by the T, that it means the same thing. So we might be starting at a time of 2 seconds.
As the day comes.
Okay, sorry about that. There's a little distraction here. Okay, so yeah, with this change in time, we were usually talking about our time as starting at 0 seconds and then ending up at maybe, I don't know, like 20 seconds. So since we're starting at 0 seconds, we can kind of forget about the little change in, because it's really like saying 20 minus 0. So we can kind of really, for grade 10, pretend like that little triangle isn't even there and it's just over t. Okay, so here is our formula. Another way of looking at our formula, however, and a lot more useful, we're going to make this change in velocity. We're going to take that and we're going to kind of flesh out what that actually means. And if we look over at this formula, we still have A, and it should have a little arrow over top of it for a vector. It's saying VF minus VI. This is the same thing as our triangle velocity, our change in velocity. But now we're saying VF minus VI, where VF is our final velocity. So that's the speed that we're going to end up going. We're going to end up at 60 kilometers an hour. Our VI is going to be the speed that we started at. So in a lot of cases, and it'll make things a lot easier, we might be starting from 0 kilometers an hour or 0 meters per second if we're starting from rest. And you guys will see in the next problem, or the problem after that actually, that makes things a lot easier once this becomes 0. And that's our initial velocity, right? Our initial speed. Okay, let's try our first problem. Okay, so our first problem says a shuttlecraft accelerates, so we know acceleration is involved, from rest to a velocity of 50 meters per second upward, that's our direction, in 4 seconds. What is the acceleration? Okay, so as soon as you see the word acceleration, we know that, well, the only formula that we have for acceleration is acceleration is equal to VF minus VI, and that F should be a little bit smaller. It's called a subscript, and it kind of goes down below, over time. That is our formula. Okay, so first thing we want to do, just to make everything a lot simpler, and I definitely want you to do it, and I'll give you marks for doing it, even if you have the wrong answer, is just write down what you have. So we're going to go through and look at all these things, acceleration, VF, VI, T, and we're just going to see which of those things do we actually have. So what I do is I just write down all 4 of those things, acceleration, VF, VI, in t. So, and then I look back to my question. I say, okay, what do I actually have? Well, it's saying what is the acceleration? So that's going to be my question mark. I actually don't know what that is. That's the one I'm trying to figure out. My VF, well, it says from rest to a velocity of 50 meters per second. So that's what's going to. That's going to be my final velocity. 50 meters per second. As soon as you see seconds, that's a really big giveaway that you are dealing with time. We measure time in seconds. So my time is going to be 4.00 seconds. Now, one thing that might throw a few people off because they're looking at this and they're saying, well, they've only got two numbers. I need to have three things to figure out my acceleration. Well, we have our VI. Our VI actually comes from the fact that our object was at rest. At rest means that it started at 0 meters per second. Okay, now that we're there, we can just punch things in. So acceleration is equal to 50 meters per second, because that's my VF, minus 0 meters per second over my time of 4.00 seconds. And if you do that calculation, you end up finding that your acceleration is 12.5 meters per second. And the units here are important. Meters per second squared. Oh, that should be a 2. I'll draw a little better so you see that. Meters per second squared. Those are our units for acceleration. There has to be a squared at the end of it, and it makes you look smart because then you're writing like something on top of the S that makes you look like a scientist. One last thing here, 12.5 meters per second squared. We do want to look at our significant digits. So if we look back to the question and I see, okay, well, my seconds had 3 significant digits. My 50 meters per second there, it had only 2 significant digits. So I want my answer in 2 significant digits. I'm going to have to round my 5 up. And my acceleration becomes 13 meters per second squared. And that would be the answer for this question.